Hello everyone. So today we will try a very interesting problem from the American mathematics competition. American mathematics competition is a math Olympiad conducted in the United States, but students from India, Europe, Australia, Singapore, anywhere can also participate in it. This is a very fun problem from a part of mathematics called number theory. Number theory is a very intriguing part of mathematics. In fact, one of the greatest mathematicians of all time, Carl Friedrich Gauss, called it the queen of mathematics. So, if you have not heard about Gauss, you should Google him. He's like the Einstein of mathematics. I like to think of it like that. So, anyway, what does this problem say? Well, it asks a very simple question. Consider the expression 2011 to the power 2011. We want to find out the hundredths place digit of this particular number. Now you can immediately see why this can be difficult. Of course, it's not possible to multiply 2011 with itself so many times. It's not possible to physically multiply it. So we have to take some other clever route. And that's the core topic of this particular problem. If you are following this channel, you know that I use problems to learn concepts. This is called the problem-driven system of learning mathematics. I think it's very beautiful. So in this particular video, the main concept that we will talk about is known as binomial theorem. So using binomial theorem, we will be able to solve that problem. Welcome to our channel. My name is Ashwini Dashgupta. I'm a faculty at chinta.com. We have outstanding programs on mathematical sciences, Olympiads, IOQM, AIM, NMTC, American Math Competition, Physics, Informatics, and so on. If you want to know more about our programs, check the link in the description for more details. So let's talk about this problem. So we want to find out 2011 to the power 2011's hundredths place digit. So what does that mean? Well, let's take an example. Consider the number 23512. This is just an example. This number has no relation with this 2011 to the power 2011. This particular digit is known as the units place digit. This one is called the tens place digit. And the third number from the right is known as the hundredths place digit. So that is what we are after. We want to find out that if we expand this expression like 2011 to the power 2011, if we actually multiply it out, what will be the hundredths place digit? So what we do is, this is a standard strategy. You write 2011 to the power 2011 as something plus another thing raised to the power another thing. This is called a binomial expansion for this expression. But the question is, what is the motivation behind this? Why should we do it? Well, the motivation is this. If you look at the expression with the last three digits as 0, and then if you add to that something small, So if you add two numbers, the first number having the last three digits 0 and the second number having something small, which is more computable, then the last three digits of the second number is the last three digits of the entire sum. So I'll explain this a little bit more, but this is the main motivation. If you binomially expand it, and if one part is a multiple of 1000, then the last three digits of this part will be 0, 0, 0. The remaining part, if it is easy to calculate, then we can just focus on the last three digits of that. So let's see how we can do this. 2011 to the power 2011 is 2000 plus 11 raised to the power 2011. And notice that just as we needed, this one is a multiple of 1000. So anything involving 2000 will have the last three digits as 0. That is, if 2000 is multiplied in an expression, then last three digits will be 0. So what happens if we binomially expand this? So I'm assuming that you know the binomial expansion formula. It's just this: a plus b raised to the power n is n choose 0, a to the power 0, a to the power n, b to the power 0, n choose 1, a to the power n minus 1, b to the power 1, up to n choose n, a to the power 0, b to the power n. This is the formula for binomial expansion, and here n choose r is simply n factorial by r factorial times n minus r factorial. This is the number of ways of selecting r things from n distinct things. So if you want to select from n things r things, this is the number of ways you can make the selection. All right? Okay, that's great. So let's go ahead and talk about the binomial expansion of this thing. So what is it? Well, it is 2011 choose 0, 2000 to the power 2011 times 11 to the power 0, 2011 choose 1, 2000 to the power 2010, 11 to the power 1. Like this, 2011 to the power choose 2010, 2000 to the power 1 times 11 to the power 2010, and the last one is 2011 choose 2011, 2000 to the power 0 times 11 to the power 2011. Okay, so what we observe is in all of these terms, we have at least 1 2000 multiplied. So the last three digits of this entire sum is 0, 0, 0. The last three digits will be 0, 0, 0. So we can just focus on this term. Just focus on this term. And what is it? Well, it's simply, this is 1, this is 1. So this is simply 11 to the power 2011. So if we just find out the last 3 digits of it, last 3 digits, we would be done. Actually, we just need the third last digit. So we don't even need to find out all the last 3 digits. So how can we find this? Well, we can again apply binomial expansion. This is 10 plus 1 raised to the power 2011. So again, if I expand it binomially, again 2011, choose 0, 10 to the power 2011, 1 to the power 0. So I'll just not write the ones because that's always there. So plus 2011, choose 1, 10 to the power 2010, to 2011, choose 2008. This is 10 cubed. 2011, choose 2009, 10 square. 2011, choose 2010, 10 to the power 1. 2011, choose 2011, 10 to the power 0. Alright, so notice again that up to these many terms, we have 10 to the power 3 or more multiplied. So the last 3 digits of them will be 0, 0, 0. We just have to focus on these 3 terms. So what are these 3 terms? Well, we have 2011, choose 2009 times 100 plus 2011, choose 2010, which is just 2011 times 10 plus 10 to the, this is just 1. So these 2 things, if they add up, if you just add them up, it will be 20110 plus 1. So 20111. Third digit is 1. Now if I can focus on this. This is 2011 times 2010 divided by 2 times 100. So this is 1005. So this is 2011 times 1005 times 100, and we have this 20111 here. So if you can directly check that this is 100500 times 2011. So the first 2 lines will be exactly same, and the third line will be completely filled with zeros, and the fourth line I don't care, because if I add all of them up, I get the third digit as 5. Here the third digit is 5, here the third digit is 1, so the third digits add up to be 5 plus 1, that is 6. That's all. So that's how we can actually solve this particular problem. I hope you learned something from this problem. The main idea was to apply binomial theorem for a number theory problem for mathematical Olympiads. Okay, if you like it, please share and subscribe, and I hope you continue to do great mathematics. I'll see you in the next one.